But I have put this all onto the Google Classroom for you. So I made this for my kids, years ago now. But it is just a very useful conversion table to have somewhere. All right. Obviously, you can't take into your exam with you, but maybe like while you're studying or revising the section, or even just going through a past paper in general. I just find this is quite a useful little tool for you, especially if you aren't super comfortable with conversions. It just sort of gives you a little bit of a helping hand, but it is split into conversions that you need to learn. So we expect you to know everything in this column on both sides. I've just split it up so that we can see everything at the same time. And then conversions that we will give you. Generally speaking, conversions that work with our measurement systems, the metric system, we expect you to know. So I expect you to know how to convert centimeters to meters, meters to kilometers, etc., etc. But anything in the imperial system, we don't expect you to know. So I don't expect you to know that there are 2.54 inches, centimeters in an inch. I don't expect you to know how many feet there are in a yard. I don't expect you to know how many ounces there are in a gram, etc., etc. Those will all be given to you. Okay, but the table is split up according to what we expect you to know and according to what will be given to you. Some of the things that I've said we expect you to know, we sometimes give them to you, particularly like very arbitrary ones. So say something like a ton, but that is something we do sort of expect you to know. And particularly something like these volumes over here on the right-hand side. So where we have like a recipe, often it's like you're baking something or someone's baking something and there's a recipe. These conversions here, sometimes they're given to you, sometimes not. If you do something like consumers or hospitality or something like that, you might know, or like economic studies, you might already know these, but I would still recommend that you know them because, like I say, sometimes they're given to you, sometimes they're not, and you obviously don't want to be caught out. Okay. Oh, guys, sorry. I woke up with such a headache, so it's been a day. So those are the only three that I would say, yes, I'm telling you to learn them, but it's 50-50. Sometimes we give them to you, sometimes we don't, but it's there for you. I think we've got a question coming up that's going to deal with them, so we'll work with them. But this is just a summary of what you should know in terms of conversions. Okay, so like I said, this is on the Google Classroom for you. I'll wait 2 seconds in case you do want to screenshot it. And like I said, generally the ones we expect you to know are the ones you already know. If you don't, like I say, they're there for you and you need to just brush up on those. And these will also help you for the next section, maps and plans. So particularly when you get to scale, understanding how many centimeters there are in a kilometer and so on. Right, the next thing that I put onto Google, oh guys, sorry, I don't know what's happening. The next thing that I put onto Google Classroom for you is just some area, perimeter, and volume stuff. Okay. Again, often we give you these formulas, and so it's not something that we expect you to necessarily know. The ones I would recommend you know, however, are for your squares and for your rectangles. Those are like our basic quadrilaterals that we work with. And so I would know how to work out the perimeter of a square and a rectangle, as well as the area of a square and a rectangle off by heart, and that's there for you in the sheet. But most of the time we give you the other formulae. Obviously, you do measurements primary school, grade 8, grade 9, and all throughout MathsLive from grade 10, if you started taking MathsLive in grade 10. And so these formulas are familiar to you and you probably do know them. But once again, it is just nice to know that when you see a formula, you know what it's talking about. So what I mean by that is, particularly with a circle, this formula down bottom left is for the circumference of a circle. So the outside length of your circle is 2 pi r or pi d. whereas the area of your circle is pi r squared. And often we get these two confused, okay? So what I always like to think is that area is always units squared, always. So the formula with a squared in it must go with area because area is units squared. Whereas the formulas without the squared, it's just a length, so it's just the circumference of my circle. Again, we give them to you, but sometimes, I don't want to say we like to trick you, but sometimes we would give you both of those formulas. So we might say something like, you may use the following formulae, 2 pi r or pi r squared, and we would expect you to be able to identify which is the correct formula to use in the given context of the question. So just bear that in mind, that there are two formulae that you can work with for circles. If it's the squared, so pi r squared, that is area, because area is units squared, centimeter squared, millimeter squared, etc. All right, but like I say, the only ones I would kind of try and remember as best you can off by heart is for the square and for the rectangle. Like I say, sometimes we do give them to you, sometimes we don't. All these other ones we do give you because they are slightly more complicated. But I would know length times breadth, which most of you do anyways. Again, this is all on Google Classroom for you, but if you want to take a screenshot, I will just wait 2 seconds. There is another little bit, or there are some more formulae, but I'll get to that now. Right, another thing, we don't actually work with triangles a whole lot. It's more circles that we work with. I've put the triangles here just in case it does come up. And so at least you know what you're working with, but honestly, it doesn't come up a whole lot in MathsLive. It's more circles and then squares and rectangles. All right, and then this little table, I'll scroll down a second, is for surface area and volume of 3D shapes. So at a grade 12 level, we expect you to work a lot more with volume and things like packaging problems. So things like, we've got a question here that's coming up, but things like you want to package cupcakes in a box or whatever the case is, and you need to figure out how many cupcakes you can get in a box, how much wasted space there is, a whole bunch of different things in terms of volume and packaging. So that's very much more grade 12 level, a grade 12 level question. Once again, we do give you most of these formulae. But what I would remember in case you ever get stuck are these sort of general formula at the top here. So general formula basically means it'll work for any of the shapes that you're given. So for example, if you forgot that the surface area of a cube is 6x squared, all you need to do to find the surface area of any shape is to work out the area of all the faces of the shape, so all the sides that make up your shape, and add them together. If you wanted to work out, say, for example, the volume of a rectangular prism, or a cube or a cylinder, it would always be the area of your base shape times height. There are specific formulas for each of them as we then look at specific base shapes. And like I said, we do give you these formulas, but it is nice to understand where they come from. But like I say, we do give them to you, so it's not something you need to stress too much about. And then just obviously, again, we don't work a whole lot with triangles. And so triangular prisms, not really something we work with. But once again, it could come up. I don't think it will, but this is also just me speculating. Anything can come up, and we would give you the formulae. So I wouldn't stress too much about it. It's more likely that you're going to have cylinders and rectangular prisms, so like boxes, that you're going to have to work with. The triangles don't really come up all that much. But again, this is all on Google Classroom for you with all these formulas so that you have it as like a information sheet, cheat sheet, or whatever you want to call it. And you can then use them going forward. All right, so we are going to have a look at some questions that can be posed to you. I have very much over prepared, so we're definitely not going to get through everything that I've sort of highlighted in your notes, but that's also not the end of the world because you do have access to all the memos. I've put the links to the memos also in your notes. So it's not the end of the world, but I would like to get through the different sort of levels of questions that we can see what we're dealing with in measurement. Alrighty, so let's get into it. So This first question is from a final from 3 years ago. I've already said to you guys that finals, I don't want to say are easier than mocks, but I do think they're a little different in terms of the way some of the questions are asked, which is why it's good to look at both of them. Often we just go straight to the November paper when we're studying, but I really would recommend you looking at both the September papers and the November papers when you're looking at past papers. All right, but let's see what we have here. So we've got a wooden L-shaped flower bed filled with soil. Below is the L-shaped flower bed with dimensions, with a D as a missing length. And we've got the dimensions, and then we've got an actual picture of what that flower bed would look like. It also makes a statement of note all corners are right angles. So basically what that means is on my diagram, if I wanted to fill it in, these would all be 90-degree angles that I'm working with. I suppose if you wanted to, you could put one there, but they're all right angles. What that does for us is if we need to break the shape up into smaller shapes that are easier to work with, it means that I'm working with rectangles. So what I mean by that is I could maybe split my shape up like that, and then I've got 2 rectangles that I could work with. I could also maybe split my shape up like that, and again, I've got 2 rectangles that I could work with. So it's important when your shape isn't I don't want to say a normal shape, but isn't a regular shape that we're used to, a traditional square, traditional rectangle. Remember, you can break it up into shapes that you are comfortable with and work with those. Right, but we'll have a look at that and see if we need to do that in a second. So the first question says, convert the longest dimension of the L-shaped flower bed to centimeters. Now, what you can see here is that I did not give you a conversion. If you have that conversion table in front of you, you will note that one of the conversions we expect you to know is centimeters to meters, millimeters to centimeters, etc., etc. So we want to convert 2 centimeters, and we need to take the longest dimension. So the longest dimension would be the 7,3 meters. Does anyone remember how many meters there are, or rather, let's go the other way, how many centimeters there are in a meter?
Is it 1,000?
Okay, so 1,000 centimeters would be a kilometer.
Okay.
So how many do you think?
100.
100, nice. Okay, so I'll show you one of the ways that I remember this as well in a second. So we have got 100 centimeters in 1 meter. So this is the conversion that we would need to use here. All right, now guys, this is, I don't want to say relatively straightforward, but this calculation would be quite straightforward. However, I am aware of the fact that sometimes we forget or sometimes we're unsure of whether or not we should multiply or divide. Okay, so there's a few ways that you can remember this. I'm going to show you a little like trick method that works with any conversion. So centimeters to meters, meters to kilometers, feet to inches, any conversion. Even when we get to like map work and scale, it will work. All right, but generally speaking, if you are going from a bigger unit to a smaller unit, you are going to multiply. So here we're going from meters to centimeters, so we would multiply. And then if you're going from a smaller unit to a bigger unit, you would divide. Okay, so that's something to remember. However, this is the way I've always taught my kids, particularly when the like conversions are a little bit trickier. So what I do is I set up a little table for myself, and it does not have to be a fancy table. It's quite literally just a T. And what you do is in the sort of heading spaces of your table, you write down the 2 units you are using. So the one that you want to convert to and the unit that you have. It doesn't matter which side you write them on. It makes absolutely no difference. So I have got meters that I'm working in and centimeters I want to convert to. If you had put it the other way around, it makes absolutely no difference. Then what you do is you write down the conversion. Okay, so you would need to know the conversion, but then you write it down. So the conversion here is 1 meter, and you write it under the meters, to 100 centimeters. And we write the 100 under centimeters because that is its unit. Once we've written down the conversion, we now write down the given value. And you put it again under its appropriate heading. So we are wanting to convert 7,3 meters. So that must go under meters. And then the trick of this method, and it will, like I say, it will work for anything, is you take this number, you divide it by the number above it, and that answer you times by 100. So I always say divide up times across. So according to this, we would say 7,3 divided by 1, which is 7,3. And then we would take that answer and say 7,3 times 100. And that will then give me my converted value of 730 centimeters. And that will then be our answer. Now, obviously, if you are comfortable just timing by 100, that's absolutely fine. But this is particularly helpful when the conversions are more complicated. So let's say, for example, you were converting something in cooking or baking. And I say to you that 5 grams of sugar converts to 3 milliliters of sugar. Then it's a bit trickier because you don't have just a 1 to something ratio or a 1 to something conversion. It's a little bit harder. It works when you're doing scale conversions in maps and plans. It works when you are, like I say, converting imperial units. This works every single time. As long as you remember to put everything under the appropriate headings, you just remember divide up, times across. Again, if it doesn't work for you, it doesn't work for you. That's absolutely fine. But this is just one of the little methods that I have found is quite useful for doing conversions. Right, when it comes to actually remembering your conversions, because like I said, it's all well and good having this trick method, but if we don't remember our conversions, it's a little bit tricky. So one of the ways I taught, and geez, I mean, it was a long time ago I was taught this, at least a good 20 years ago. However, I don't know how many of you have don't know how many of you have heard it, is King Henry. So King Henry died a miserable death, old measles. And this is then our units of measurement. So kilometers, meters in the middle, centimeters, millimeters. This capital H at the end there is hectometers, decameters, decimeters. We don't use those, so you don't really have to stress about them. But when it comes to conversions, they need to be there to help us, and I'll show you why in a second. This does also convert to both weight, so kilograms, grams, milligrams, as well as volume. Kiloliters, liters, milliliters. It all works. And basically, it follows the procedure that we spoke about earlier, that if you go from big to small, you times, from small to big, you divide. So we were converting meters to centimeters. So we're going big to small, which means we're going to times. And basically, every jump I make to get to the unit I want, it is a multiplication by 10. So times 10, times 10, 10, which in this case is a multiplication of 100. If, let's say, for example, I wanted to go from, I don't know, liters to kiloliters, I'm now going from small to big. So I divide, and every jump, that's a really bad jump, every jump would be a division by 10. So divide by 10, divide by 10, divide by 10, which basically means that I need to divide by 1,000 to go from liters to kiloliters. So King Henry is something that I learned, like I say, when I was just a wee child, and is something that has stuck with me ever since. I teach all of my kids King Henry because I find it quite useful. I even have him up in my classroom. But King Henry died a miserable death called measles. I think there is a much nicer one with kittens. I never learned the kittens one, so I don't know the kittens one, but you could probably Google it. But that is what I use for conversions in the metric system. So kilograms, meters, liters, milligrams, anything like that, it will always work. Okay, and like I say, we use this logic that I wrote down here, the fact that anytime you go from a small unit to a bigger unit, you times, and a big unit to a small unit to a big unit, you divide. Right, that will always be the case. And so when it comes to conversions, sorry, I just opened up my charger. When it comes to conversions, that's just really helpful to know. And if you learn it, when it gets to your exam, you can quickly write that at the top of your exam paper, and then you have it there to use as you go along. Sorry. Someone on our street thinks they're very cool. Okay. Any questions about any of the conversion stuff I've spoken about? I know this is still like a beginning question, but all of these tools are helpful. Okay.
No, ma'am, we're good.
Okay, cool. I will assume that you guys will jump in with questions, okay? You guys are good at that, so I assume that if you have a question, you'll jump in. All right, so the next question says calculate the missing length D. Right, so if we go and have a look at D, here it is. And what I want you to notice is that if technically we extended this side over here and all the way across, we would just form a big rectangle. And so what that means is that this bottom length down here should also be 7,3 meters. I've already accounted for, I already have 5,2 meters of that 7,3. So to get this missing little bit here, I would just need to figure out, well, what do I still need to add to 5,2 meters to get 7,3 meters? And to do that, we just subtract. So 7,3 minus 5,2 meters is equal to 2,1 meters. And that's it. And now that we know that, I like to put information that I have found or that might be useful to me on my diagram so that if I'm now asked further questions about it, it's easy enough for me to go and do whatever calculations is required of me. So this length D over here is 2,1 meters. Oh, I say whatever, but it'll annoy me. Right. And guys, remember MathsLive, no 1 mark questions. So even like something like this would technically classify as a 1 mark question, but in MathsLive, we don't do 1 mark questions. It's 2 and up. All right. 1.3.3 says the volume of the flower bed with materials can be calculated. I'm going to start that sentence again. The volume of the flower bed with materials can be calculated as follows. Volume equals 2,1 meters times 3 times 0,5 plus 5,2 meters times 1 times 0,5 meters, which is equal to 3,15 meters cubed plus 2,6 meters cubed minus 5,7 meters cubed. Show which value in the above calculation represents the height of the flower bed. Right, so again, I haven't given you any formulas here, and this is why I said to you earlier, knowing the formula for just the basic square and rectangle 2D shapes, as well as the cube and rectangular prism 3D shapes, is really useful to you. So remember I said earlier that you can break the shape up into rectangles. I just want to have a look. Okay, so you can break the shape up into rectangles. And so technically, if you work out the volume of this rectangle, and the volume of this rectangle and add them together, you basically have the volume of this entire L-shaped planter. And you could figure out how much soil you would need, etc., if that was something we wanted to do. Right, but because we're working with rectangular prisms, again, we need to obviously know the formulas that apply here. So if this is my rectangular prism, again, it's probably a formula that most of you know already, but because I can draw a straight line really well. Right, okay. Not my best rectangular prism in the world, but it's okay. We're not here for art. This would be your length, this would be your breadth, and this would be your height. To work out your volume, you would say length times breadth times height, which is what they've done here, okay? So if, for example, we take this first bracket that was given to us, which was the 2, 1 times 3 times 0, 5. The 2, 1 comes from that D length we just found. The 3 from the length and the breadth, so that's where we get that, which means that this 0, 5 at the end here must be the height of my L-shaped planter box. And you can check this with the other bracket as well. 5, 2 is the length of the rectangle times 1, the breadth of the rectangle, times the height, 0, 5. And so all they've asked us to do is just state the value. And so 0, 5 meters is how tall or how deep the L-shaped planter is. So again, understanding your formulas and where they come from is really important when you go ahead and answer these questions. However, if you were confused, remember the only picture that has dimensions is the flat L, okay? A flat picture doesn't have a height. A 2D shape doesn't have a height. So what you could do is if you were a little bit confused or you weren't too sure which one it was, you could just go and tick off which dimensions you have. So what I mean by that is they've given you a 2, 1. There's 2, 1. They've given you 3. They've given you 5, 2. And they've given you 1. Now, obviously, 7, 3 can't work because that's the whole rectangle length and we've split it up. But that would mean that the 0, 5 that appears in both is the height. So there's a few different ways that you can go about thinking of this, but it is just really important to understand the basics of the formulas that you work with. Right, and that is like a question 1 level measurement question. Obviously, you'll get maps and plans questions as well, but that's it. It is really asking you the basics of. I can't remember which past paper it is, but I know it's in your notes. There was one that in question 1, sometimes they ask you to define certain things. So they might say like define perimeter in this context or define area or volume or whatever in this context. And so knowing what a definition of all of those things are is important. Your textbooks will all have them, a formula, a definition for all of those things. But obviously you can just Google it if you're studying and you want to write down definitions, but it's also something that generally you know. Okay, so every now and then in question 1, they'll ask, define this term, but nothing too tricky. And again, it would be worth 2 marks, nothing super ridiculous in terms of mark allocations for a definition. All right, so I'm just going to go there for you guys to screenshot that if you want, and then we'll have a look at a question 3 level question where it's really more focused on measurement and more in depth in terms of the measurement we ask. Okay, guys, remember, like, for example, this whole conversion trick thing that I showed you, you don't have to use the things I'm telling you. Okay, if you feel it's too complicated, if you feel it doesn't work for you, if you feel your method is better, go for it. I'm just giving you suggestions that might help. All right, so if we look at question 3, good golly. Right, CD needs a bookshelf to store her files. She decides to buy a second-hand wooden bookshelf with 2 shelves as illustrated below. I remember this question so distinctly. Anywho, we have been given a few dimensions of the bookshelf, and it's important to take note of what dimensions you have been given. So for example, this 80 centimeters on the side is the height of my bookshelf, the entire bookshelf. We have also been told that the height of one shelf in the bookshelf is 40 centimeters. So I'm just going to say height of shelf. And we know that the length of my bookshelf is 162 centimeters. They've also given us some information on the side here, which is all sort of given to you already. But it's importantly telling us that the inside width is 162 centimeters. Remember, the wood has a thickness. So if you were to measure from outside, that would be slightly more to accommodate for the thickness of the wood. The total outside height, 80 centimeters. The inside height of the bottom shelf is 40 centimeters. And again, remember that this wooden piece, the wooden pieces on the side, all the way around, that would all have a certain thickness. That's just something to bear in mind. Excuse me. And then they've said at the bottom, as I told you earlier, sometimes we give these to you, that the area of a rectangle is equal to length times width. Something you probably already know, but they have given it to you, so you never need to panic. That information is there for you. So the first question asks, or the first question says, the top shelf has a thickness of 1,5 centimeters all around. So what that's saying is, if this is my top shelf over here, I'm going to get it right. Okay, there's my top shelf. Woo. You get what I'm trying to do. It didn't go well, but there's my top shelf. Okay. And then we've got the inner section of my shelf, exactly as I was explaining now. The wood all the way around it. So this border all the way around is 1,5 centimeters thick. So if you went and actually measured it, it'd be 1,5 centimeters. And the first question asks, sorry. The air is fighting me today. Determine A, the outside length of the bookshelf. We can see A illustrated at the top for us. So we can see that it's from end to end, but now including or accommodating for the outside lengths, the actual thickness of the wood. So what would I need to do here in order to calculate the outside length of my bookshelf? Any ideas?
I really don't know.
Okay, that's okay. This is why we're here. So in my beautiful diagram that I've drawn at the bottom here, essentially what we're looking for is this total length here, A. And what we need to remember is that we have been given the inside width. So if we go back to our information, they told us that the inside width is 162. So I know that this inside bit of my shelf is 162 centimeters. And they've also told us that the wood that we are working with is 1.5 centimeters thick. So this is 1,5. And this on the other side, 1,5. Also top and bottom. But right now we're not too concerned with that because of the fact that we want the length, not the width. And so basically what we need to do is we need to add all of these lengths that make up A at the bottom. So this would be the 1,5 plus the 1,62 plus the other 1,5. That will translate directly to my length of A. And if you have a look here, let's do this. Okay, so if I do this yellow line, if I take it all the way down to match up with A, that's the length of A. That is what we're wanting. So all we need to do here is we actually just need to add together the 1,5 centimeters, that is the thickness of my wood, as well as the length of the inside of my shelf. And so that would mean for me that A is equal to technology. A is equal to 1,5 centimeters plus 162 centimeters plus 1,5 centimeters. There's a centimeter there as well, but it doesn't matter. So 1,5 plus 1,5, sorry, I'm doing this in my head. You can obviously just type this into a calculator. 1.5 plus 1.5 is 3, plus 162 is 165 centimeters. So what we now know is that this outside length of my bookshelf is 165 centimeters long. So if we now compare that outside length to the inside length, the inside is shorter because it accommodates for the thickness of the wood on either side. And guys, if you need to draw it out like I've done here to visualize what measurements you have and what you're looking for, then do that. Okay, I like to draw pictures for myself, especially if I'm not completely understanding what the question's asking me. If I draw it out, often I can then see what they want from me. But just remember that wood has a thickness, or the border, or whatever you want, whatever you're working with. But in this case, the wood has a thickness. So if we want to then include the outside length, which would include the thickness of the wood, the length of the shelf, and the thickness of the wood on the other side, we have to add all of those things together. Right, does that make a bit more sense now in terms of how we would approach this? Again, this is not like the easy questions. Okay, good. So these aren't the easy questions. These are not supposed to be just like straight off the bat easy. And so it's absolutely fine when we have questions or we're not too sure. But like I say, I know you'll just let me know if you're not with me. All right, so then it says the base of the bottom shelf is, I nearly said 45, is 4,5 centimeters thick. So what that means is this base at the bottom here, which makes sense. I mean, like the bookshelf needs some sort of stability. This base will probably be a bit thicker than everything else. This base is 45. Oh, I said 45. 4,5 centimeters thick. So if you just think of a bookshelf, generally that bottom bit is thicker than the rest to keep that bookshelf stable. It then says calculate B, the inside height of the top shelf. All right, so again, maybe a little diagram might be useful for me here. It's not going to be the most beautiful diagram I've ever drawn, but when have I ever drawn a beautiful diagram for us? We've got our top shelf. And we have our bottom shelf. And again, we're now just going to think about all of the links we do actually have. All right, so we have just been told that this bottom bit over here is 4,5 centimeters. Sorry, I know I'm squishing it at the bottom. I just want to be able to see all my other dimensions. We were also told that the height of that bottom shelf, right at the beginning, it's on the diagram at the top there, the height of the bottom shelf is 40 centimeters. So this bottom shelf is 40 centimeters high. We know that this little gap over here, because we've just worked with it, is 1,5 centimeters. And what we're trying to calculate is B, as you can again see on the diagram at the top there. So we're trying to look for the height of my top shelf, which is represented by B. And remember again, we know that this width of the wood around the shelf is again 1,5 centimeters. The other thing you also know is the outside height of your bookshelf. So if you took into account the bottom thickness, the shelf, the wood in the middle, the shelf, the wood at the top, the entire bookshelf is 80 centimeters in height. And this is now going to help us because basically what that's saying to me is if I add together all of these little links, I'm going to grab a highlighter here. So if I add together the width of the wood, the height of the first shelf, the width of the wood, the height of the second shelf, and the width of the base, I must get 80 centimeters. This beautiful red line that I've drawn here is the total height of my bookshelf. Now, I already have all of the dimensions except for B. And so what that means is I need to work backwards. Now, there's a few different ways you can set this up, but basically we know that 80 centimeters would be all of these measurements combined. So 1,5 plus B plus 1,5 plus 40 plus 4,5. And so if we want to then get B or find the value of B, we would need to say 80 minus all of those values. And what that ends up giving us is that the height of the first bookshelf or the top bookshelf or B is equal to 32.5 centimeters. Excuse me. Right, so because you've got basically everything that you need to make up the 80 centimeters except for one dimension, you can subtract them all and get what you're missing. So the height of that top bookshelf, slightly less than the bottom one, 32.5. Atia?
Ma'am, I am confused.
Okay,
wait. Did you get the 8?
The 8 or the 80?
The 8, the green arrow one.
That's a B. Sorry. That might help, hey?
Okay.
So sorry. Yeah. It helps if I write things clearly. Yes, that's a B. I do apologize. It's this one over here in my diagram.
Okay. Okay.
Sorry.
But can you please explain it again?
Okay. No problem. All right. So let's fix my handwriting because as you said 8, I was like, oops. Okay. Oops, we took the flash off. We took the flash off again. All right. I'm just going to leave the working out there. We can take it off if we need to. Let's get rid of all of that. Oops. Okay. It's going really well, but it's fine. Okay. Right. So if you just, and let's actually maybe make this a touch smaller so we can see both of the diagrams. Okay, we can see the top diagram. We can see my beautiful rendition at the bottom here. Let's take that off. Let's take that off. Okay, so what we know, and I will try and make my handwriting clear, from this diagram at the top, we know that from top to bottom on the outside of my bookshelf, that is 80 centimeters. So what we need to remember is that then includes, if we go and highlight, this base thickness at the bottom, which we were told is 4.5 centimeters thick. It includes this entire bottom shelf. It includes the thickness of the wood in the middle of the two shelves. It includes the thickness of my shelf at the top, and it includes the thickness of my wood at the top. Okay, so all of those little thicknesses, all of those little widths needs to essentially add together and give me 80. If I add all of those things up, I must get 80. So then we go back and we say, okay, well, which of these lengths do we actually know? So like I say, right at the bottom here, we know that the width of this wood down here, let's maybe do it like this. So the width of the bottom shelf is, or the base of the bottom shelf is 4.5 centimeters. We then know that the bottom shelf, according to the diagram that was given to us, you can see over here, the bottom shelf is 40 centimeters high. So from the top of the shelf down to the base, that is 40 centimeters. We then also know, because in the previous question it told us that the thickness of the wood, so this little yellow bit over here and the yellow bit at the top here, those are all 1.5 centimeters. Now we'll make this diagram bigger now in a second. We just want to work with both. And the final thing that I have been asked to find is the inside height of the top shelf, which I'm going to write my B much better now, is B. So what we need to realize is that, that's a little bit excessive. If we were, and then I go and do something so silly. If we were to go and add all of these values together, right? So if I were to go and take the thickness of the wood at the top, plus the height of the first shelf, plus the thickness of the wood in the middle, plus the height of the second shelf, plus the base, I must get 80 centimeters. All of those things added together give me 80 centimeters. And so that's exactly what I've done on the side here. If I added all of them up, I would get 80, which means to get B alone, I would have to say 80 minus all of those little lengths to figure out the missing height of my first shelf, which is represented by B. So what we just need to bear in mind is that all of these little widths, the thickness of the wood, the shelf, the thickness of the wood, the shelf, and the base must add together to give me 80. And so we would then subtract from 80 to figure out the missing height of my top shelf. Does that make a bit more sense?
Yes, ma'am. I understand it now.
Good. Good. It's really tricky when you have so many dimensions that you have to work with, especially if they aren't written on the diagram for you.
Yes.
All right. So guys, again, like this will help you, it won't. Sometimes to take, I was going to say something now, it's gone out of my head. Sometimes to like take the shape that you're working with out of the diagram, like I've done here, is a little bit helpful. Or sometimes to scribble on your diagram and fill in what you know is helpful. You do what you need to do to help yourself, obviously. That it is trickier when you don't have all the information on your diagram and you're now trying to work with stuff that you don't actually have in front of you or isn't written down for you. All right, so 3.2 says the total outside height of the bookshelf is 31,496 inches. Okay, so immediately inches, it's not really something we're super familiar with, but that's fine. We'll get there. So why do I keep saying 3? 31,496 inches. Determine, rounded to 2 decimal places, the conversion factor for the height in the form 1 inch equals. Okay, we're not going to panic about this. What it's asking me to do is, I know I've got 31,496 inches, which is the outside height of my bookshelf. But I also know that the outside height of my bookshelf in centimeters is 80 centimeters. So what we need to bear in mind is that those two values are actually equal to each other. Yes, there are different units. One is inches and one is centimeters, but they represent the same measurement. They both represent the outside height of your bookshelf. And because they represent the same value, we can put them equal to each other. So I'm going to say it again. Because we already know that the That's going really well, isn't it? Okay, let's try that sentence again. Because we know the outside height of your bookshelf is 80 centimeters, and because we've been told that in inches, it's 31,496 inches, we know that they're the same thing. They represent the total outside height of my bookshelf. So we can make them equal to each other. Now we go back to what they actually want from us. So they have specifically told us that they want the conversion factor to represent 1 inch. So what I mean by that is, if you look at this last sentence here, it says, in the form, 1 inch equals some centimeters. Now, what that's doing is it's giving me a little hint in terms of what I need to do. It's telling me that this inch value needs to become 1 inch. And we need to remember that whatever manipulation we do to get 31,496 to be 1 inch, we need to do the same manipulation on the other side. Now, we know that if we say 31,496 divided by 31,496, if you divide the same value by itself, you get 1. So that's great. That's going to give me 1 inch. But now I need to remember that I've divided by 31,496 on the left. And so I have to do the same thing on the right-hand side. And this will give me my conversion factor. So if I now say 80 divided by 31,496, I get what 1 inch is in centimeters. And this would be 2,54 centimeters. And this is what we call a conversion factor, exactly what the question was referring to. A conversion factor is something that we can use to convert one unit to another. So now if I gave you, 57 inches, you could use this conversion factor and convert those 57 inches into centimeters. Atia?
Ma'am, so we can't go from, like, we put the conversion factor, and we can't go from 1 inch divide by 31,496 and then times that by 80 to get the 2.54 centimeters. Will it work or no?
So if you're thinking of that little method I showed you earlier, we would just need to be careful, because the first thing that we write down is the conversion factor. So we would have inches, we would have centimeters, and because we don't actually know what the conversion is, it would be 1 is to something, and we would want to find that something. So we would have 31,496, and we would have 80 centimeters. So you almost need to go backwards now. So now you need to go and say 80 divided by that value and then times up. So instead of going divide up times across, you would divide across times up. You need to go backwards to get back to the conversion factor. So you could use it, absolutely. Yeah.
Okay.
It just means that you have to swap the trick. So like I say, instead of divide up times across, it must be divide across times up. And that will then give you your conversion factor. Yeah.
Okay. Okay, thank you.
Yeah, sure. So this is why I like this method so much, because it does work for so many different things. But again, if it doesn't work for you, don't use it. Right, so we do have a conversion factor. So if it gave us another inch measurement, we could now convert it quite easily. Right, 3.3 says, CD bought the bookshelf at a discounted price because the backboard, which covers the entire width and height of the bookshelf, needed painting. She decides to do the following. Remove the backboard, paint the back of the board with a single coat of paint, paint the front of the backboard with 2 coats of paint, and then nail the backboard back onto the bookshelf. Right, so before we get into all of that, let's just understand what the backboard is. So if we just take this off, I'm actually just going to move this picture down for us. So I'm going to take all of this nonsense off first. Okay, so here's my bookshelf. The backboard is basically the back of the bookshelf. So everything, it would be one piece of wood just sort of nailed on. Everything here at the back. So all of this, obviously all the way back, just not including the shelf, all of that is backboard. It's one solid piece of wood that we put at the back to sort of close up our bookshelf. All right. Now, obviously, we've already calculated quite a few things. So I'm going to fill that in so that we know what we're working with. We know that this B value over here was 32,5 centimeters. We know that the thickness of the wood around the top shelf is 1,5 centimeters. And we know that this bottom base over here is 4,5 centimeters. Cool. So we're going to take that back piece off. We're going to paint the back of it with 1 coat of paint, and we're going to paint the front of it with 2 coats. So this would be the front of it. Makes sense why she would want to paint it with 2 coats. She wants it to look nice. 2 coats it is. And then she's going to put it back on. So 3.3.1 says calculate in centimeters squared the area of one side of the backboard. So importantly, it's told us exactly what units it wants us to work in. And when it says one side of the backboard, basically all it's asking you for is what is the area of the backboard? Because one side, it's the same shape, right? So if this is your backboard, it's the same shape on either side. You're just going to plonk that onto the back, and that's the back of your bookshelf cupboard. So it's essentially just asking me, what is the total surface area of your bookshelf? That's it. Now, we know that the total height of our bookshelf is 80 centimeters. And we know that the total length of our bookshelf is 165 centimeters. I'm pretty sure that's what we worked out at the start. Yes, it would help if I wrote that on. 165 centimeters. All right, now, again, just remember, it would be the outside length and the outside height because you want it to cover the entirety of your bookshelf. You can't just ignore the pieces of wood because that's where you would need to nail the backboard into. So we would need to actually have the whole outside area of our bookshelf so that we can actually nail it onto our bookshelf and close up the back. Now, guys, please remember whenever you're calculating an area or a volume, so important. We don't often trip you up with this, but we can. Please remember that your units must be the same. So what I mean by that is if one of these units was in meters and the other in centimeters, you would have to convert. Now, when converting, always go back to your question and always make sure your units are in what your question has asked you for. So because this question has asked me for centimeters, or centimeters squared rather, I would want to make sure that all of my measurements are in centimeters squared. Are all in centimeters, because if you try and times meters by centimeters or kilometers by meters, you're not actually getting anything meaningful. The units must be the same in order for us to get an answer that means something. Now, it did say right at the start that the area of a rectangle is length times width, and that is now going to be useful to us. Obviously, if you already knew that, it didn't really matter that they told you that, but they have told us. And so we can now use that piece of information to help us calculate the area. So area of our rectangle is length times width. We know the length is 165 centimeters, and we know the width is 80. And so we just multiply those two values together, and that gives me 13,200 centimeters squared. And so now what I know is that this entire back of my bookshelf has an area of 13,200 centimeters squared. Atia?
Ma'am, really, really silly question. The centimeters squared, right? If you get your answer in centimeters, you just have to add the 2 on top to make it squared, right?
Yes. So the reason for that is, like, this is going to like grade 8, grade 9 exponents. If you've got centimeters, because it's 165 centimeters and 80 centimeters, remember, if you said x times x, you could write that as x squared. We are saying centimeters times centimeters, hence centimeters squared.
Okay.
And that's why for volume, it would be cubed, because for volume, you would say centimeters height times centimeters length times centimeters breadth, centimeters cubed.
Okay. So there's no other, like, you get your centimeters answer, and then there's no other calculation to get into centimeters squared. You just put the 2 to make it centimeters squared.
Yes, exactly.
Okay. Thank you.
Pleasure. All right. So we have the area. That's great. And now, of course, because they want it to be difficult, they are going to ask us to convert the answer that we've just gotten to meters squared. Right, now there's 2 ways to do it. One is quick and easy, one is not. I'm going to show you both, because I personally think the one that is not quick and easy is probably the easier one. But I'll show you both and you decide. Right, if we just take a little scroll all the way back up to some conversions, you should probably know. It's going to be awkward if I haven't written it on here. Right, so for whatever reason, for the last few years, they've been quite mean with this. Even though I've said it's a conversion that will be given. Oh, no, wait, that's a volume. It would be really helpful if I was looking at the right thing here. Even though they've said this is a conversion that will be given, they often like to test whether or not you can convert units squared. So what this is saying to me is that 1 meter squared is 10,000 centimeters squared. Now, I'll explain where that conversion comes from now. But yes, it says it will be given, but for whatever reason in the last, I'm going to say like 5 or so years, it's actually something they haven't given you and they've expected you to do it by yourself. Now, again, I'll show you 2 different ways to do it, because I do think that this conversion to remember is quite tricky, because it's not the one that traditionally makes sense to us, but you can decide what makes sense for you. All right, so the reason it is, excuse me, this value is because if you had a square that was 1 meter by 1 meter, if you worked out the area of the square, you would say 1 times 1, so 1 meter squared. However, if you took exactly the same square, but these measurements were now in centimeters, you would have 100 centimeters by 100 centimeters. And so if you worked out the area in centimeters squared, it would be 100 times 100, which is 10,000. And this is where this conversion comes from. 1 meter squared equals 10,000 centimeters squared is exactly where it comes from. So if you took a 1 by 1 meter square and you took the area in meters, nice and easy, 1 meter squared. However, if you took the area in centimeters, it would be 10,000. Now, we can't just go and use the normal conversion that we're used to of 100 centimeters is 1 meter, because it's not just one length that we're working with. In area, and it's exactly what Atya just sort of elaborated on or alluded to. In area, you are working with a length times a breadth, or a length times a height, or you're working with 2 dimensions that you're multiplying. And so we have to bear that in mind when we go and convert something like this. So either you just go and learn this conversion, and this would probably be the only one in the ones that I've said you should know that you maybe need to learn, just in case it pops up. But I will show you a way to do it without needing to learn that. Okay, so we're going to use this conversion. 1 meter squared is equal to 10,000 centimeters squared as our first method. There we go. So method 1 is to use the conversion. So 1 meter squared is equal to 10,000 centimeters squared. This then becomes quite easy. All right, we can now use that little trick method that I showed you earlier. So we put it into our table. It works for area as well. We have meters squared and we've got centimeters squared. We write down the conversion factor. So 1 meter is 10,000 centimeters squared. And then we write down under the appropriate heading the unit or the value we want to convert. And that's this 13,200. So under centimeters squared, 13,200. What we now do is we divide up, times across. 13,200 divided by 10,000 is 1,32 times 1 is still 1,32 meters squared. So basically you just divide by 10,000. Now, this method relies solely on you knowing that 1 meter squared is 10,000 centimeters squared. If, however, you did not know that, and this would be my advice that you do, because it's now asking you to write this. Okay, let me start those words again. Because it's asking you to do the same calculation. So it's still asking you for an area, but now in meters squared. I would go back to my rectangle that I'm working out the area of. We know this is 165 centimeters and this is 80 centimeters. And I would do exactly what I said to you in the first question. This question is asking me for an answer in meters squared. And so what I'm going to do is I'm going to make sure that my units are in meters. 165 centimeters is 1,65 meters, and 80 centimeters is 0,8 meters. Just do the conversion, because now what you can do is you can work out the area and say 1,65 times 0,8, and that will give you 1,32 meters squared. This method, there is absolutely no need for you to remember that conversion. And I always tell my kids to do the second method. The reason being is because if you try and convert to meter squared and you are not 10 million% sure of your conversion, the likelihood is that you will just times by 100, not 10,000, or divide, whatever is appropriate for the situation. So my advice is always, if they are asking you to give the same answer, just in different units, go back to the original dimensions, convert them to the units you want now, and then you go and do the calculation. So even though it said convert the answer, you've done that. You've just used a slightly different method. And so my advice is always go back to the original, put the dimensions in what you want, and then you just go and work out your area or your volume or whatever it is. I would not try and convert it with a 1 meter squared to 10,000 centimeters squared unless you are 100% sure that you know that conversion factor. If you are even 99% uncertain, just go back and convert your originals. Atya?
Ma'am, for the 2 marks, the conversion we go with the arrows divide and then times. Would they give you your 2 marks if we put it with arrows, or do we have to write it out full and be like 13,200 divided by 10,000? get an answer and then take that answer and times it by the 1? Or can we do it with the arrows?
You can do it with the arrows. I would then just make sure on your arrows you've put obviously the direction of the arrow correctly, and then you put the division and you put the times.
Okay, so they would give you your mark.
Yeah, absolutely, because you've shown what operations you've used. You've shown that you've divided. And so, yeah, absolutely.
Can we put both of them?
When you say both of them, as in like write it out and do the table?
Yes.
If you wanted to. But like I say, as long as you show what operation you're using and the direction of your arrow, they'll give you full marks.
Okay.
Yeah. Alrighty. Excuse me. So 3.3 says 1 liter of paint covers 6,9 meters squared. Determine rounded to 2 decimal places the number of liters of paint required to paint the backboard completely. Great. Okay, so firstly, take note of the fact that they're giving us the spread rate in meters squared. So I'm actually going to use the answer that I've just found, this 1,32 meters, because that is the same unit as what I'm now given here. Okay. However, we have our board. We've got the back of our board, which remember requires only 1 coat of paint. And then exactly the same board, because it'll have the same area, same dimensions. We now have the front of our board, which we were told requires 2 coats of paint. And that's just important to know because it says it's required to paint the backboard completely, back and front. Now we know that this area is the same. So the 1,32 meters squared that we have already determined as the area, that's the same for back and front because it's the same shape. But now we need to be very careful. If we are going to paint 1 coat of paint on the back, okay, so there's my 1 coat of paint. I've painted it beautifully, lovely. I'm only covering 1 area once. So I'm only going to cover 1,32 meters squared here. So 1 coat will require me to cover 1,32 meters squared. However, when it comes to the front, I'm painting 1 coat, lovely, 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 which will cover an area of 1,32 meters squared. But because I now need to paint a second coat, I have to cover another 1,32 meters squared. And so what that means is that 2 coats covers the area twice. And so when we now talk about, or when we now need to consider painting the backboard completely, I need to take all of these areas that I need to paint and total them up. So that basically means I have 1,32 for the back, 1,32 for the first coat on the front, and 1,32 for the second coat on the front. This will be the total area that I need to paint. So when I add all of those up, I get a total area of, and okay, there's a few different ways that you can do this, but I get a total area of 3,96 meters squared. Now I know how much I have to cover. It then goes on to tell me that 1 liter of paint covers 6,9 meters squared. So if I only have 3,96 meters to cover, I'm definitely not going to need a full liter of paint because 3,96 is much less than 6,9 meters squared. But once again, we can use the trick method if we wanted to. That's up to you. And seeing as we're on a roll with the trick method, let's go there. So remember, think about the 2 units you're working with. You're working with your area, meters squared, and the liters of paint that you need. So you write down your conversion first. 6,9 meters squared covers 1 liter, or 1 liter covers 6,9 meters squared. And we are going to write under the meter squared heading the number of meters squared, or the area I need to paint, 3,96. Right, as I've just said, fill in your arrows with the direction, put in your operation, divide up, so 3,96 divided by 6,9, that answer times 1, and you get that you only need 0,57 liters of paint. Right, it said rounded to 2 decimal places, so please make sure you round off correctly. But that's it, right? So even if you, because I know that it's sometimes hard to like comprehend, I know how much 1 meter covers, but this is how much I need to cover. How do I now like put these 2 bits of information together? I know that's tricky. And so this is again why this little trick method is so nice, because even if we're really struggling to understand what's being asked of us, just plug your values in, do the divide up times across, and you're going to get your answer. Right. Alternatively, as Atia said, you could write it out if you wanted to. And the way I don't know why I'm saying the way we write it out. Writing it out basically is saying that I have got 3,96 meters squared to cover, and I need to figure out how many 6,9 meters squared go into that, because for every 6,9 meters squared, I've got 1 liter of paint. So I need to figure out how many liters, and that will give me exactly the same answer. All right. Again, I prefer this little table trick method just because, like I say, if I'm struggling to understand something, I can set up my table, I can plug in my values in the right spots, and I'm going to get the answer. It is sometimes hard to comprehend what the situation is. All right. But again, think back to logically, and Ati, I do see your hand. Just think back logically. What you want to cover is 3,96 meters squared. 1 liter covers 6,9. 1 liter covers a lot more than what you need to paint. So it should be less than 1 liter that you are needing for the painting of your backboard. Atia?
Ma'am, can you please show the markings, because the question is out of 5. This is very little calculations.
Okay, so remember I said to you, don't panic about the mark allocation, because we are quite generous with marks.
Yes.
Okay, there are a few different ways that you could also do this, answer this question, but based on what we've done, excuse me, you would get a mark for multiplying or adding your area 3 times. So understanding that you would need essentially 3 of those areas. Excuse me. And then you get a mark for the total area that you are needing to cover with your paint. You would then get a mark for dividing by the 6,9. You would get a mark for the answer that you get, and you also get an additional mark here at your answer for rounding. So that's why I said it's so important that you round off correctly, because there is a whole mark allocated to rounding here. So if you have a look, the marks are generous, right? It's a mark for timesing by 3 or adding 1,32 3 times, a mark for getting the total area you need to cover, a mark for knowing you need to divide by the 6,9, a mark for your answer. So technically, even if you screwed up the rounding, you've still got 80% for this question, and then a final mark for rounding off correctly. Okay, so that's where those 5 marks would go. And like I say, don't, particularly in Maths Lit, I'm trying to think there's another subject that's also generous with marks, but I can't think about it now. Don't, just because it's 5 marks, don't think that you need to have a page worth of working out. The marks are generally very generous in higher mark allocations. Just because a higher mark allocation does generally mean it's a slightly harder question. So we try and be quite nice with our mark allocations to try and give you maximum marks if you can't get the final answer. Okay, makes sense.
Yes, thank you, ma'am.
Cool. All right, so whoopsie daisies. 3.3.4. Don't know where I got 3.3. So anyways, TD stated that 1 500 ml can of paint is sufficient to paint the backboard completely. Verify with calculations whether her statement is valid. Okay, now again, bear in mind what you have just worked out. You have just determined the fact that we need 0.577 liters of, okay, that's a weird looking 7 and it's going to upset me. So let's go back. 7 liters of paint. That's what we need. We have just determined that. That's it. Now, again, think back to your units. The question is referring to units in milliliters. Your answer is units in liters. So you're going to have to convert one of them. It doesn't matter which one you convert, as long as you get them to the same unit, you will be able to answer this question. Now, personally, I always convert the bigger unit, because if you convert the smaller unit, you're going to end up with decimals. It doesn't matter, like I say, it makes absolutely no difference. So you decide. But I always prefer to convert the bigger unit. So what I mean by that is, I want to take the 0.57 liters and I want to convert this to milliliters. You can use King Henry if you want. You can use the trick method if you want. You can just go ahead and multiply if you want. Whatever. It is completely up to you. I'm going to use our little trick. So our units, milliliters, liters. Obviously, like I say, you do actually need to know your conversions, but this is quite a nice, easy one. There are 1,000 milliliters in 1 liter. And so I write that conversion in, 1,000 milliliters for 1 liter. And then I write in the value I want to convert under the correct heading, 0.57. Go back to what we need to do. Divide up, times across. So divide up, times across. 0.57 divided by 1 is still 0.57. 0.57 times 1,000 is 570 milliliters. Again, if you can just straight away times by 1,000, that's absolutely fine. But oftentimes we get confused between whether we should times or divide by the conversion factor. And so this is why this trick method is so useful. You never have to question, oh, should I be timesing by 1,000? Should I be dividing by 1,000? You chuck it into the table and you divide up and you times across and you'll always get it right. Okay, so this gives us 570 milliliters. Obviously, that's not my final answer because the question asked me to verify. So verify means tell me if her statement is correct. Yes, she is correct. No, she is not. So she has said that 1 500 ml can of paint is enough. Well, no, I need 570 mils, not 500 mils. So we can say, therefore, no, she is incorrect. Okay, so she needs just more than 500 mils. And like I said, because the question said verify, we actually need to do that. And again, if you think about it, and in reference to Atya's question, 3 marks is quite a generous mark allocation for this question, because really all you've done is converted and said no. But you're getting a mark for understanding that you would need to times by 1,000 or timesing by 1,000. You're getting a mark for the 570 mils. And then you're getting a mark for your verification. So even if you forgot your verification, you've got 2/3 of your marks. You got 67% for this question, even if you forgot the verification. All right. So particularly in questions like this where it says verify or prove whether she's correct or whatever, and we did a few of those with the finance, the verification, that last statement, yes, they're wrong, no, they're not, whatever, that's only 1 mark. The bulk of the marks comes from your working out. And so our working out here, like I say, I got a 67% straight off the bat just by doing a very simple conversion that we all know. Right, I have just realized that I have not given you any chance to take screenshots of this question. So let's just scroll back up here. I'm not actually sure what I did screenshot and didn't screenshot. So we're just going to do this. And you can take screenshots from here, and then I'll scroll down to the rest. And guys, I would definitely classify this as a harder question, all right? It is definitely a more complex question, particularly with the verify and the converting the meters cubed and stuff, meters cubed, meters squared. So definitely a slightly harder question, but it really does come down to understanding what the question's asking. Right, here's 3.2.
Ma'am?
Yeah.
What the method, we call it the divide and conquer one, the table one that you use.
Yeah. Love it. Divide and conquer. Love.
Can you use it for literally any conversion? Like
Yep.
it will literally work with any conversion.
Yep. Any conversion. As long as you know the conversion factor, it'll work. So let me just scroll down so you can take the last screenshot. So for example, the one where I particularly like it, and we'll use it again in maps and plans, is in cooking. So sometimes what they'll say is, particularly if you want to convert from a liquid to a mass, so like I think margarine or butter is 5 grams of margarine is the same thing as 3 milliliters. That's quite a hard conversion to work with. So if I now say to you, okay, cool, you've got 125 grams, how many milliliters do you have? Chuck it in, grams, milliliters, 5 grams for 3 moles. You're converting 125 grams, divide up, times across, and you get your answer. So it literally works for anything.
Okay.
Yeah. And
That
yeah,
is good.
it's a good, I like divide and conquer. I'm going to call it that from now on. Alrighty, guys, it is 4 o'clock. There are all your screenshots. So we've had a look at sort of the basics. We've had a look at the more complex questions that you can encounter with measurement. I might chuck in one more measurement question in maps and plans, just because honestly, maps and plans is my worst section in MathsLit. It's also the smallest section, but we will look at maps and plans. But I might just throw in like a packaging question so that you can see how it's asked. And then we'll have a look at some maps and plans. But that will be our last session on Saturday. I apologize that I could not speak English today. Who knows what happened? It escaped me. It didn't want to cooperate today, but that's cool. We pushed through. But I hope you have a lovely rest of your weekend, and I really hope that your exams go well when you start on Tuesday. I don't know why. Yes. Or just exams in general. I hope they go well. And I hope that, Atia, I hope Friday goes well.
Thank you, ma'am. Thank you.
All right, guys. I hope you have an awesome rest of your weekend. Stay warm if you are somewhere cold.
You too, ma'am.
Thank you.
Ma'am.
Yeah.
I just want to say I wrote a paper last week, and it was on finance, like the income tax and all of those things. And your flow diagram that you showed us really, really helped me.